Hello, we are going to be looking at the homogeneity property, and this property applies to power functions. For a power function, we have the equation y equals c times x to the k power. This k power is known, it is not a variable. And this c is a positive constant. X and y are our two variables. And so let's take a look at our first example. It says the speed of a certain animal is related to the length of its stride by a power function. So our two quantities instead of x and y are speed and the length of its stride. So I'm going to assign variables. S is speed and L is length of stride. When I am trying to take words and make an equation, the order matters. So since this came first, this is going to be in my equation where y is, and this came second, so this is going to be in my equation where x is. Second sentence, it says the value of the power in this function is k equal to 1.06. So I'm going to write a formula. I have speed, I have speed is equal to some unknown constant times L, the length of the stride, to a power of 1.06. Now, I wrote this by putting the L in parentheses instead of using the dot like I did here to symbolize multiplication. I did this because they're asking us to multiply the length of the stride by different amounts, and that multiplication actually happens inside the parentheses. And so I feel like the parentheses make it a little bit more obvious as to what's going on than just using the dot for the multiplication. So taking a look at part A, it says if the stride length is doubled. So we know that doubled means to multiply by 2, and the thing that we're multiplying by 2 is the length of the stride. So going to my equation, I would have that the speed is now whatever constant, doubling, so 2L to the 1.06 power. So how is the speed going to be impacted? Well, as I look between my original equation and this new equation, the c, the constants, are the same, so that's the same impact. The L, the length of the stride, is the same impact. Exponent, the same. The thing that is different is this 2. This 2 is inside the parentheses because it would be first multiplied by the L and then raised to this power. So how is the speed going to be impacted? It's going to be impacted by 2 to the 1.06 power. I put that on my calculator and I get 2.08 times as much. If I had had an exponent of 1, if I doubled the length of the stride, I would exactly double the speed. But because I have an exponent that is not 1, when I double the length of the stride, I slightly more than double the speed. Let's take a look at a second example, part B. This time the stride length is to be tripled, so we understand that to be times 3. So again, stride length is some constant. We now have, this is speed, is some constant, 3 times the length of the stride, and still the exponent of 1.06. So how is this going to affect speed? Well, the impact would be 3 to the 1.06 power. And again, I do that on my calculator, and I get 3.2 times as fast. So, as we talked about before, if the exponent had just been 1, tripling the length of the stride would triple the speed. But because we have an exponent other than 1, tripling the length of the stride does a little bit more than triple the speed.